Okay, so for the last presentation, we're going to go over decimals, which we've kind of already been over when we went over fractions. In fact, we actually see fractions in some of these problems. But anyway, let's just get on with it. The first problem is asking us to find fraction form of decimals. The first fraction we have is 0.225, which we put those decimals over powers of 10, and since there is 3 here, we actually put it over 1,000, which I've done over here, and then we just simplify that by dividing each side by 25 to get our fraction in simplest form, and we get 9/40, and then to find the prime factorization of the denominator, I just used 4 and 10 because those are the biggest numbers that I could see that would easily go into 40, and I just created a simple little factor tree. If we had been over before, I did 4 and 10, and then we've got 2 and 2 and 5 and 2 for our factorization of 40. B is the same way. We've got 0.36 over 1,000, 0.036, excuse me, since there's 3 numbers, we put it over 1,000. Each side can be divided by 4, and we get 9 over 250. And then we find the factorization of 250, which again I used 10, but this time I used 25. Then we've got 5 and 2, and 5 and 5, and those are all prime numbers. So we keep it that way. For the summary, I know it's kind of hard to read, but to summarize, we're basically changing decimals to fractions. We do that by placing the value of the number after the decimal over its corresponding number. Then it is a power of 10. Then we just simplify. We then find the prime factorization, which I have done by creating a factor tree. Next, we are finding graphs and creating little scenarios to given equations, and the first one is y equals x over 2, and then so I said every 2 days my dog gets 2 treats, and that's just a simple graph with an upward slope. For this one, this slope is going to go downwards, so this is like the number of treats he gets as it goes up. In this one, sorry, I should have explained it more. As days go on, he gets more treats. This one is every 2 years my uncle cuts down a tree that is in the yard. So it would go down because this is the number of trees. We have it on this axis this time, so it would go down over the years. But the slope would still be the same. It would not, beside it being negative, it would be kind of equivalent. It would not be way steeper or way less steep. It would be the same in that aspect of things. In this next problem, it is y equals 10x. So this one, the slope is going to be really large. Every 10 minutes, my goldfish completes a lap around his bowl. So basically, for every 10 we get, then we add one more. On this axis, we've got 10, and we only do 1 for this. So it's a very steep axis. For this one, it is using square roots because we're squaring x. I could not think of an equation for this one, but it does pretty much create a U shape on the graph, and it follows numbers that are squared. So that's my very creative equation that I have came up with. So to summarize in this problem, we are graphing equations. These are very, very simple equations, so the graph is constant in its direction. The first 2 equations are just opposite of each other. The next one has a steep slope. The last one is a function of x being squared, and it makes a U shape. I think I did this one backwards. Where is the rest of mine? I have to pause it for just a second. Okay, we are back, and for this picture, if you see, it's a little different. I had a little bit of issues getting, for whatever reason, it did not want to show up on the scanner, so I just had to use a picture of it. I tried to make it show up on the scanner, and I eventually just decided to use what I had. But anyway, for this one, we are given boxes, or shapes, I should say, not boxes, because the last one's a circle, and a certain percentage of the shape is shaded, and we have to figure out what percentage that it is. So for the first one, as you can see, it's kind of broken up into 4 distinct pieces if we just ignore the shaded part for now. And we know that 1/4 is 25%. So we just got 1/2 of that fourth that is shaded, which is 1/8. We can find the percentage of that, or we can say that half of 25 is 12.5. So we know that the shaded proportion is 12.5%. This one is broken down into 9 boxes. So I rounded to the nearest whole number, and I said that each box is about 11%. So we've got 3 that are shaded, 1, 2, 3. It's hard to see again, I apologize. But 3 would equal 33, and then half of 11 is about 5.5. So if we add it together, we get 38.5%, and this one is just simply 50%, because it's just half of the circle. To summarize, we're looking at percents based on visuals. We can also use what we already know about percents. For the first one, we already know that 1/4 equals 25%. If we cut that in half, we get 12.5%. The second box, each square is about 11%. Then we add 3 whole squares and a half of a square. The circle is just simply cut in half. So again, the circle is just simply 50. For this one, we assume that the shapes are perfect because my drawing is not. But we've got a hexagon here, and that is going to represent our whole number, or 100%. This is half of that, so that's 50. This is 16.67%, and that is of this. This is 33.3% of this. This is 38.5%, and then this last one is 19.2. I do a little visuals here to kind of help better understand. But we can see that this little triangle will fit into this rhombus twice. Again, that is given that I did these perfectly. I did not, and I apologize, but use your imagination. So to find the percentage area of this, we can just divide 33.3, which we know that this is a third because this can fit in here 3 times. And 33.3333 continuing, so on and so forth, is a third. That's its percentage equivalent, but we just rounded, of course, to make things easier. This one's 50 because it can fit in there twice. And then these other 2, you just kind of have to visualize putting it in there about how much it would be. To summarize, we're finding percentage based off a specific whole, which in this case is a hexagon. We are seeing how much space each of the other shapes take up. We then are changing that into a percentage. What is going on here? I've got it backwards apparently. Or I missed one. Let me pause it one more time and I'll be right back with the proper picture. Okay, so for this one, I was asked to create problems based on specific numbers, I guess, that they are given. The first one is if we're given A and B, what percent of B is A. So for my problem, I did, for the holidays, my mom makes 12, which is A, different types of holidays goodies. She has made 7, B. What percentage has she made? And she made 58.3% of her holiday goodies. Out of 9 Christmas inflatables, my dog has popped about 44% of them. How many has he popped? For that problem, we are given B and the percentage, and we're looking for A, which is the other number. And he has popped 4, which is his true story. He actually does pop 9 inflatables every year, so we've kind of just stopped buying them. And then this one, my cat likes to hide all of his toys. So far, he has hidden 3 of them, or 5%. How many total does he have? So for this one, we're looking for the whole number, but we are given a percentage and a small number, and the total of his toys would be 15. I am creating percentage problems. There are 3 different types. One I am finding that equals percent of a whole number. The next one I am finding a number based off a percent, and then the other one I am looking for the whole number based off the smaller number and the percent. And then finally, we are creating equations. I chose to do this one because I know New York City has a lot of restaurants, and I thought it would be really interesting to see how long it would take to go to all the restaurants if we went to 3 every single day, which of course would cost a lot of money, and it's not possible, but it's hypothetical. So Jane lives in New York City where there are about 24,000 restaurants. She wonders how long it would take her to go to all the restaurants if she went to 3 a day. I set up a proportion where I've got 3 over 1 and she goes to 3 in 1 day. So there's 24,000, and how many days does it take? So if we set up our equation, we get 3x equals 24,000, which we would just be dividing 24,000 by 3, which would get 8,000, which I divide that by 365, which is approximately 22 years to go to all those restaurants. And then I just set up a table and a graph based on that information. I am creating a proportional equation. It is one where I can find the answer to by using cross multiplication. Then I have created a chart and a graph based off of that same information. And that is all I have for you today.